Hello, Med. Thank you for the opportunity to visit with you about bioremediation. And we're looking at different ways that we can adapt our products into the Libyan market. As our history of our company, when it got started, Medina products were first made in 1962. The products were designed to stimulate the microbial activity of the soil, generate more health in the soil, and improve crop production. These are very fundamental benefits that are used in bioremediation also. When our products were first used, they were used in areas where there was a lot of salt contamination. The microbes were able to break the salt apart, help the salts migrate, and that in a way is remediation also. Bioremediation is a process where microbes are used to break down a contaminated area, and the end result of the breakdown is proteins and dead microbes, and all of that turns back into fertilizer. If you look at oil, oil is a hydrocarbon that was originally plant life, and the plant life turned into these hydrocarbon bonds, and when they are broken down and consumed by bacteria, it becomes back into organic matter, which is utilized as fertilizer for plants. One of the other projects where our products were used that was similar to bioremediation in the early stages of our company back in the early 70s, farmers were using a chemical herbicide called atrazine. Atrazine was a herbicide, it's a hydrocarbon, and it would keep certain plants, small grains, from growing. Atrazine was used on corn, but if a farmer wanted to rotate to a small grain, the herbicide was still there and causing problems getting the small grain to grow. Farmers found that when they used our product, the Medina Soil Activator, the hydrocarbon herbicide was degraded and disappear where they could plant their crops. A researcher, Dr. Microbial Piotrowski, looked into this, and he realized that if we could break down herbicides, we would also be able to break down hydrocarbons. In his first project that he used our products on, he was breaking down creosote as a contaminant in an area. He was very successful in this project, and this was before the Valdez spill occurred in Alaska. When the Valdez spill occurred, because of the work that Michael Piotrowski had done, we were brought into the project early. One of the few companies that were tested for remediation, and we were proven to be successful. However, bioremediation was really not used in the Valdez spill. The technology was developed and was proven to be successful. We've done projects on the North Slope in Alaska. We've done projects in Estonia, Sweden, Denmark, China, and various areas all over the United States. We feel our remediation techniques are very effective because they are flexible. We separate the components into the bacteria is sold by itself. It's a blend of many known hydrocarbon degrading bacteria in a dry form. The benefit of hydrocarbon degraders in a dry form is a longer shelf life. You wouldn't want to buy product, keep it, store it, ship it, not use it if there was a shelf life. The dry materials can be stored for up to 2 years, and we found that many times we would sell product to someone, they wouldn't use it right away. That's why we sell the bacteria in a dry form. Bacteria, another component is a nutrient component. That product is called BioD. You can increase the amount of BioD. You can decrease the amount of BioD depending on the type of contamination and the conditions that you're working in. The last component is the Medina Microbial Activator. This is the product that helps make a better environment in the soil for the microbes to grow. Just think of it as a way to condition the soil, allow more biological activities to work, and take in oxygen. These are all the factors that are needed in remediation. You need the bacteria, you need the nutrients, and in order for bacteria to eat hydrocarbons, they need nitrogen, phosphorus, and carbon. The carbon is coming from the hydrocarbons. We supply the nitrogen and the phosphorus in the ratios that is needed, and we can increase or decrease depending on the contamination. The other factors that are needed is oxygen, supplied by the tilling of the soil, and you need water. So it's very important how the projects are managed and set up initially. We have some proposals or ideas on ways that a highly contaminated large area can be operated, and we have some graphs and spreadsheets that will show a little bit more detail on how this could work. Okay, what we're looking at now is a spreadsheet, and this is used to calculate the amount of products that are used and the length of time that it takes to clean up an area. In this example, we're looking at a soil that starts off at 50,000 parts per million of hydrocarbon, and we know that remediation works in half-lives. In other words, if you're 50,000 parts per million in a certain period of time, it can be cut in half or down to 25,000 parts per million, and basically in that same length of time it can go from 25,000 down to 12,500. So that is what we use to determine the length of time. We estimate in this scenario that the half-life is 30 days. We're estimating that the soil is going to be tilled and worked to a foot in depth. We're going to keep the soil moist. We're going to aerate it. We're going to use a large tiller to get oxygen into it. And from this, we calculate the amount of products. Also, in this scenario, we're determining that we want the soil to be cleaned to a level of 10,000 parts per million. You can go lower than that, but this is where we feel you would have gotten the oil contamination down to a level that is not harmful. There won't be odors being generated into the air, and eventually it will get more cleaner, but that is where we're looking at is saying that is an accepted level in this example. So from this example, you can see we go 50,000, 25,000, 12,500, 6,250. At that period, after 3 cycles, we have reached that level. We're using 1 cycle months. Applications of products, we're going to apply the Bio-D nutrient, the microbial activator, and bacteria. The second application would be just nutrients and activator, no bacteria. The third application would include bacteria again. This area here shows the amount of product used per cubic yard. In this example, this is 16,130 cubic yards of soil. So it calculates for each replication, these are in gallons, 807 gallons of Bio-D, 323 gallons of microbial activator, 484 pounds of bacteria. We would use the liquid products 3 times. This example is only showing bacteria once. total amount of products for those amount of cubic yards. Pricing, these are estimates. We are not sure what the cost of freight and what the product would eventually cost once it's landed and ready to use. But the estimated prices for all the products, $37,975. The cost per cubic yard, if you look at it as the yards that are being treated, is $2.35. However, the amount of contaminated material that is brought into this site is actually half of that. What we're proposing is that you would excavate the soil from the contaminated area, move it to a treatment cell, apply it 3 inches deep in the treatment cell, and then when you till it and mix it, there would be dilution at the beginning, so you would be treating twice as many yards of soil as you brought out. That's why the cost for the cubic yards of soil, this $2.35 is the cost of the soil that's treated. This is the 16,000 cubic yards. About 8,000 cubic yards of contaminated soil would be brought to that site. So on the 8,000 cubic yards of soil removed, the amount of product cost is $4.71. And these are factors that can all be changed. You can use less product, take a longer period of time, but this is a recommendation that we would make. On this spreadsheet, if you jump back to the main sheet, it goes into how the calculations are made and what kind of input factors are used. The green areas are factors that are inputted. The purple areas are the calculated factors. And off on the side, there is a graph that shows the level of contamination and the decrease, and the red line is where we want to get to. So I'm going to go through some of the factors that can be inputted into this spreadsheet. If you were to make a treatment area that is 20 acres in size, you can enter the amount of acres that you have here. We've entered 20 into this scenario. You could make that smaller, you could make it larger. You have the width and the length that you enter, and if you're hauling material from the contaminated area and excavating it, you can enter the amount of cubic yards that you would haul in a truck, enter the depth of soil that you are putting in the treated area, and the TPH, or the petroleum contamination of the soil that's being excavated. If you see in this scenario, we are adding 100% of clean soil. In other words, we take 3 inches of contaminated soil, and then later on we would till it to at least a 6-inch depth. So the level of contamination after blending is immediately taken to 50,000 TPH, or cut in half. If you change the level here for the soil, and if you say you're only going to add 50% of soil, then the TPH of the soil after blending is changed. The graph also shows the change. The other spreadsheet on the hydrocarbon contamination, it affects the starting level, the level that you start off with. Instead of 50, it's 66, and it shows the length of time that it takes to get there. So all of these factors are combined together. I'm going to go ahead and change this back to the original starting point of 100%. So we want the goal to be 10,000 So we also have the duration of the cycle. If things were better or slower, we could change that. We could change this to 15 days instead of 30, and all of those factors are brought into effect in the spreadsheet. Going to take it back and leave it, at well, I'll have to fix that later, but leave this at 30 days. So we have a factor here also that's what would happen if it is more adverse conditions. We have it at 3. That goes into this worst case scenario, some of the calculations. Another thing that's needed is the amount of water. We're recommending that it's going to take half an inch of water per cycle or per month. If you have a pump that is 100 gallons a minute, you would put 100 here. If you have a pump that can irrigate faster, you would change that number. The weeks between watering, we have 4 weeks. And if you have a lake that you're pumping out of, you could put that amount there. So from that data, then it calculates over here the amount of gallons that you need per event is 271,000 gallons of water. And with this size pump, it would take 45 hours to water that whole area. And if you're treating the whole thing for the 3-month period, that's where this 814,000 gallons is where that number comes from. Going back up to the first area here, these inputted areas, this is what's calculated from that. So you would need to haul about 469 truckloads a month into the treatment cell, and square foot, here we go into the cubic yards that can be put into that 20-acre area. You would be able to bring 8,067 cubic yards of contaminated soil, and you'd put it 3 inches deep. We'd blend it, we'd bring it down to 50,000. If we knew what the starting contamination was, we could plug that number in there and target all of these calculations. And that pretty well explains those calculated areas. Now the next step, other than watering, is spreading the soil. This spreadsheet goes into a lot of detail, has a lot of information to help manage a site. But we calculated if you were using a motor grader, the dump truck would dump the soil. You want to spread it uniformly. We were looking at using a grader. It would take about 3 minutes for the road grader to spread the soil that was hauled in one truck. The cost of that machine is about $85 per day. Fuel cost, fuel is 10 gallons per hour to operate the machine, and operator to drive it. In the United States, we figure $25 per hour for that operator. So you have the total hours, the machine cost, the fuel cost, and the operator. We're using a cost of fuel at $3.25. Your fuel of diesel probably is much less. So that is the spreading time. The other operation is tilling it. We're proposing in this scenario the use of a BOMAG. A BOMAG is a very large tiller that's used in highway construction. You can use smaller equipment. We've proposed for some operations and we currently are using a 50 horsepower tractor with a creeper gear that goes very, very slow. Still does an excellent job. Depending on the size of your project, you could change the equipment. The BOMAG, though, is suited for very large projects. The width of the machine is 7.66 feet. It travels at 100 feet per minute. Rental cost $87. Fuel consumption per hour 12 gallons per hour. We would be tilling every week. So weeks between tilling is 1. Operator costs $25 an hour. If you pay your people less, just change the number to a different amount. Over here, we calculate the speed that becomes 1.1 miles per hour, and the minutes to till 1 acre. It's roughly 1 hour to till an acre, so it's taking 19 hours to till the whole 20 acres one time. Your machine cost, your fuel cost, your operator, total trips, and going down to tilling the whole area, the whole lift, enough times to get it to the target treatment. This is the dollars to do it one time. The total times to get that area to the clean level is 34,000. Then this area is bringing the cost of the remediation from the tab over here, bringing it back to this spreadsheet. The cost per yard of soil that's treated, and that again, we're treating double the amount of soil that was brought over. The cubic yards that were contaminated is 8,000. The cubic yards of the soil that we're treating is 16,000. But the total cost of the lift then is 37,000 for the products for that whole area that's being treated. And let me get this a little smaller. For certain projects, we include a management fee depending on how much we have to do. We calculated that at 50 cents a cubic yard, and then when it's completed, and that depends on how much involvement we have to do as a company. Glad to help you every way we can. Taking the whole area, though, we have the spreading cost, we have the tilling cost, the remediation products, and the total cost per yard is $75,000. There are some more numbers below that I can't get to. The next operation would be when you have this area that's treated and cleaned, and if it took 3 months and you excavated the area and taken out about 8,000 cubic yards of soil, at the end of that 3-month period, you would then have an area where you could use the same area and bring in more contaminated soil and place it on top of the soil that you have treated. On some large projects like this, we've set up a area, and when one area is clean, we add new contaminated soil on top of that and continue treating. So you do another 3 months. You bring in the soil, put it on top, and then till it into the other soil that has been cleaned. So a dilution factor is important. If the soil is so contaminated that it doesn't take water and it doesn't take oxygen because it's so oily and packed and just tight, then you want to blend it in with soil so it is more manageable. That's what's very important on very, very oily soils. So again, you would take contaminated soil, put it on a site, treat it for maybe 3 months until it gets to a clean level, and then bring in new oily contaminated soil, contaminated sites, put it on top until it mix again. I know as you review this information, you will have ideas that you can share with us on how that system would work. Another system is to work the soil in place, but usually where the contamination is, there are pipelines, there are equipment, there are tanks, and it's yes, it is a cost of moving the soil to another area, but many times that's necessary to do it properly. Time, and when you have more information on how the system or how contaminated the soil is, we can review and make more recommendations on how this would work.